I'm migrating a multi-tenant application from Azure VM to Azure Kubernetes Service. Observability is one of the few things you have to solve because once your app runs in containers, you cannot simply RDP to a server and check for the log files anymore. So I picked the industry standard Fluent Bit, which is CNCF graduated with billions of download, and it failed for half of my cluster. Today, I'll show you what broke, how I fixed it, and I'll prove it works with a live demo at the end. On VM, debugging is straightforward. You simply RDP to a server, check for your log files, and search for the errors. But in Kubernetes, your app runs in pods, and pods they restart, they move between nodes, they scale up, they scale down, and the log files you are relying on, they are gone the moment your pod restarts. So you need a system that collects these logs before they disappear. That's first pillar of observability, getting visibility on what's happening inside your cluster. Let me show you what we are working with. We have a Azure Kubernetes service with Linux nodes. That's where most of our workloads run. And we have a Windows node required to run a legacy .NET Framework API. The requirement is simple. All logs, regardless the OS, should end up in one place, collected, processed, stored, and visualized. Simple. My first choice was Fluent Bit, which is CNCF graduated, lightweight, and battle tested in Linux environment. It is widely accepted in compliance heavy environment. It works perfectly on Linux nodes, but on Windows node inside AKS, it doesn't. And it's not a misconfiguration, it's a known limitation, and there is already a GitHub issue open for it and closed. So I'm stuck. Half of my cluster is generating logs and half of my cluster is silent, and I have a decision to make. For Windows, there is a solid option, Grafana Alloy. It works on Windows really well. It's Grafana native and it's successor of Promptel, which is retiring this March. So now I have two real options. Option A, use Alloy everywhere. One tool, simpler operation. But it's new on Linux environments and I would be betting everything on it. Option B, I can use each tool where it's strongest. Means I can use Alloy on Windows node and I can use Fluent Bit on Linux nodes. But I'll have two options, two tools to manage. Which option you would choose? Well, I chose option B with a strategy. And here is what most people miss while running two tools. The log content is identical from both the tools. The only difference is the metadata attached by these tools. So here is the insight. Loki doesn't care which tool sent the log. It only cares about the label so that it can store the log, process the logs and store them accordingly. So if I keep my metadata formatting identical between both the tools, everything downstream stays the same. Here is the label from FluentBit and here is the label from Alloy. If you can see, this namespace and this namespace, both metadata are different, but these and these are the labelings which I have done. For pod name, again, you can see the output matches. For container, again, the output matches. And same for the nodes, the output matches. And we have only two config files with same labels. That's it. And if I migrate to Alloy only tomorrow, my dashboards don't change, my queries don't change, and my storage doesn't change. And this is one of the config decisions most people miss. Now let's see where the logs go. Both agents sends logs to Loki. Okay, so let's point this to Loki. Loki does two things. It collects the log, process it, and store it in Azure storage for long-term retention and makes them queryable in Grafana dashboard. So let's add Grafana dashboard as well. Grafana, and so storage gives us compliance and cost control, and Grafana gives us real-time visibility. Same logs, same labels, one experience. Enough discussion. Let's jump to the demo now and see everything in action. Let me first show you the UI pod which I'm running. So ingress and tenant UIs. Tenant UI is the namespace in which the UI pod is deployed. And you can see there is one tenant deployed, and this is the host URL. So let me quickly go to that. Let me log in. And if you can see, there are couple of services has been used: the auth API for login, the product API, the legacy greet API, a sample greet API, and this is again a product API. Okay, so let's see these pods where they are running. So get pods, ingress, namespace, shared services, and you can see these are the services we simply the app was trying to access and made the request. Perfect. Let's see the observability section now. So kubectl get pods and ingress observability, and let's see the daemon set. Here it is. You can see the Alloy is running on Linux node, Windows node, and the Fluent Bit is running on Linux node. And here are the pods for Alloy, Fluent Bit. You can ignore the rest of them. We can discuss them in the next video. And all the logs go to Loki dashboard. Perfect. Let's quickly Loki collector, and it processes it and stores in the Azure storage. So the Grafana dashboard was the right word, but let's see. So kubectl port forward and svc Prometheus Grafana, then namespace observability and port. Perfect. Let's access the Grafana dashboard now. And let's go to explore. The data source is already selected as Loki. Let's quickly select the OS. As you can see, I am able to see both Linux and Windows OS here. And this was because the labels were same. So I can choose Windows node. I can check for the logs. They are coming. Let me quickly change it to Linux, and again the logs are coming. Let's change the label to pods and check for Linux related endpoints. So let's quickly go to auth API, which is running on Linux pod, and see. So the logs are coming as expected. It's generating less logs, that is why it is visible that way. Let's see the other product API, and we can see there are a couple of and a lot of logs are coming from product API. Let's quickly go to legacy API, which is coming from Windows node, and we can see the logs. So if you will see, the label was same. I was only changing the pod values, but the label was same, and this was because of the configuration we had. Same labels, same dashboard, same queries. The source doesn't matter anymore. If I migrate to Alloy only tomorrow, nothing changes here. This wasn't about Fluent Bit versus Alloy. It was about hitting a real constraint, like Fluent Bit doesn't work on Linux Windows node inside AKS Cluster, and designing your solution around it, using each tool where it's strongest, but standardizing the metadata. And that's how you keep your future migrations boring. What option you would have chosen? One tool everywhere or two tools with clean contract? Let me know in the comments and subscribe the channel for more such videos.